Example 1. Given the following information about the polynomial function f of x, find the remaining zeros of f. So we're given that we have a degree 3 polynomial, and it has zeros 3 and then 3 plus I. So we know that if it's a degree 3 polynomial, then we must have a total of 3 complex zeros. So they're giving us 2 of them. We just have to find the third. So we know that one of them is imaginary, and those imaginaries come in pairs. So if we have 3 plus I, its complex conjugate would be 3 minus I. So our remaining 0 is 3 minus I. Example 2. Form a degree 3 polynomial with real coefficients that has zeros 1 and 1 plus I. Okay, so again, degree 3, we need a total of 3 complex zeros. They're giving us 2 of them. One of them is imaginary, so we know that if one of our zeros is 1 plus I, its complex conjugate, 1 minus I, will also be a 0. So we know our third 0 is 1 minus I. So 1 minus I must also be a 0. So if we want to form a polynomial f of x, and we have the zeros, we know that we can find corresponding factors by taking x minus the 0. So if 1 is one of our zeros, we can find a factor, x minus 1. And then if 1 plus I is one of our zeros, now I'm going to use brackets because I want to enclose that complex number in parentheses. And then I want to take x minus 1 minus I. So now we just need to multiply all this out, and I would definitely recommend pairing up the imaginaries. So I would pair up these two and multiply these first and then distribute the x minus 1 through. Rather than taking x minus 1 through one of these, I would take the imaginaries together. So I'll rewrite my x minus 1. Now, I want you to look at the brackets here. I want you to look at this as a binomial. Obviously, it's not a binomial. There's more than 2 terms. There's 3 terms in the brackets. But I want you to treat this imaginary number, this complex number, as one term. So this is x minus this number and x minus this number. I want us to look at it that way so that we can FOIL to distribute our multiplication. So we'll pair up our first terms in the brackets, x times x, and we get x squared. Now we'll take our outer, we want to take the x times this negative 1 minus I. So if we have a positive x and a negative 1 minus I, we'll have a negative, and then we'll just sit that x right next to the 1 minus I for multiplication. Then we'll look at our inner terms. Again, look at the 1 plus I as one term. So I have a negative 1 plus I and a positive x. So I'm going to have a negative, and then I'll just sit the x right next to the 1 plus I for multiplication. And then the last 2 terms, these are the complex numbers. We have negative times negative, so that'll give us a positive, and then just sit the 1 plus I and the 1 minus I right next to each other to indicate multiplication. So I'll rewrite my x minus 1 here. Now, we need to distribute through these parentheses here. So I'm going to distribute, so I'm going to remove the brackets because I'm going to remove these parentheses on the inside here. So I'll have x squared. Now I've got negative x times 1, so that's negative x. And then I've got negative x times negative I, so that's plus ix, or xi. Now I distribute this negative x to the 1 plus I, so negative x times 1 is negative x. Negative x times I, negative ix. Now here I want to multiply out the 1 plus I and 1 minus I. And if you remember, you can look at this as a plus b, a minus b. So if you want to just remind yourself, remember when we multiply a plus b and a minus b, you could FOIL to distribute your multiplication, but you're going to see that you're just going to get a squared minus b squared. So in this case, our a is 1, so 1 squared is 1. and our b is I, so minus I squared. Okay, so now I'll again bring down my x minus 1. And now we've got to combine some like terms here in the parentheses. So I've got my x squared here, so I'll just bring that down. Now I've got an x, a negative x, and another negative x, so I've got negative 2x. And then here I've got the ix and the negative ix, so those will add up to 0. Here I've got a 1, and then we recall that I squared is equal to negative 1. So this is really a negative 1. So I'm taking a minus 1, so that's going to give me a plus. So this is really 1 plus 1, which will give us 2. So now if you look, we started with those imaginaries, the i's in there, now they're gone, and that'll always happen. When you multiply the two factors that contain the imaginary zeros, they're going to multiply out, so you only have real coefficients. And see how in the directions it said use real coefficients? It will always multiply out. Those pairs will always multiply out the imaginaries, so you have only real coefficients. So now we just need to continue to distribute. So I'm going to distribute my x through the parentheses and then my minus 1 through the parentheses. So x times x squared is x cubed. X times negative 2x minus 2x squared. X times 2, 2x. And then take the negative 1 through the parentheses. So negative 1 times x squared, negative x squared. Negative 1 times negative 2x, positive 2x. Negative 1 times 2, minus 2. And then finally, we combine our like terms. We've got x cubed minus 3x squared plus 4x minus 2. So we do have a degree 3 polynomial with real coefficients. Now we can take a look at the graph. If we enter our function in here, x cubed minus 3x squared plus 4x minus 2, on a standard viewing window, zoom 6, so we can see one x-intercept, which makes sense because one of our zeros is real, but the other two are imaginary. So like it sounds, imaginary zeros have no graphical significance. You can kind of think of it like imaginary zeros, you can't see them on the graph because they're not real, because they're imaginary. So the only ones we can see are the real ones. And if we look at that certainly looks like it's an x value of 1. We could look at the table. And we do see 1, 0, so that verifies our 0. So if you guys want to make a little sketch in your notes, so we've got a 0 here at 1, 0, and just get that approximate shape. So you can just note here, you can't see the imaginary zeros.